Hey guys, I wanted to send a quick reminder for how to solve systems of equations because you're going to need it for one of your problems on your proofs. So we have a situation where you have an equation that has two variables or more than one variable. You're not able to solve for one of those variables unless you set up a system of equations. So you have an example where you're going to have a problem with two variables and it's going to ask you to solve for or prove that x is something or y is something. So that means that you've got to solve for x. So in this situation, if you have two unknowns, you're not able to solve for a single letter unless you have two equations and set up a system and then solve both x and y one at a time. So there are three ways that you can solve systems of equations. And graphing, not ideal. Definitely possible. You can put it in slope-intercept form and plot the lines and find where the two lines intersect, but definitely not convenient, especially if you don't have grid paper. So I would choose either substitution or elimination. And I'm going to demonstrate both because this system here is actually a good example for both of those, and then you can just choose whichever one you prefer. All right, so again, we have two variables, but we have two equations. Therefore, we can solve for both of those variables just one at a time. I'm going to start with substitution. So the substitution method is where you're going to get one of these letters by itself, and then you're going to plug the other part back in for the same letter down here. Because remember, with systems, you can't solve if there's two unknown, but if you make one of them semi-known, then you can work with it and get it all just one variable, then you're able to solve. So let's make one of these equations all the same variable. So what I'm going to do is I'm going to make my x plus y equals 5 something of just x equals. So I'm going to move my y, and I'm going to have x equals 5 minus y. So now I kind of have what x equals, and I'm going to be able to use this and substitute it in for the next equation in the place of that x. So for instance, I'm going to do 5 times, and instead of writing x, I'm going to write what I found x to be, 5 minus y. And then I'm going to keep my equation going, minus 4y equals negative 2. So let's pause right here and remind ourselves why we just did this. Remember, you cannot solve an equation if it has two variables in it. But if I take one of those variables out and replace it for something that now includes the other variable that was already present, then I can solve. So now this equation here only is working with y's, and so I'm now able to solve this because there's the same variable present. So now we are going to solve this by distributing. And then we're going to solve by combining like terms. And then I'm going to move my 25 over. And I get negative 9y equals negative 27. Divide by negative 9. And how many of you are actually doing proofs in your head while I do these steps? Y equals positive 3. All right, so now we have one of those pieces, that y equals 3. And then I just need to take that and plug it in. You could plug it into the new problem that you found. You could plug it back into the top or the bottom for any of the y's that you see, and I'm going to plug it back into the one that I found because it's already set up for x equals now. So x equals 5 minus, instead of y, I'm going to put 3. X equals 2. So that is a review of substitution to solve a system of equations. For your proofs, you are just trying to solve one of those, so whichever one you need to solve for, and then choose whichever method you want. All right, let me show you the elimination method if that's the one you prefer. With elimination, you want to eliminate one of the variables because, again, you cannot solve a problem or an equation if it has two variables in it. You got to eliminate one of the variables and then plug it back in later. All right, so elimination, remember your goal is to find one make it the same coefficient, so number in front of your letter, but opposite signs. And so right here, I could make this negative 5x, or I could eliminate my y's and make this times 4. So whatever you want to do. I'm going to do, just because I like to be on the outside here, I'm going to make that a negative 5 that I'm going to multiply to all pieces in here. So that would make my new equation negative 5x minus 5y equals negative 25. Some of you might have chosen to multiply a 4 to this because this one was already negative. But either way would work. You'll get the same answer. And then this is when you add these two up. So these two would cancel out, eliminating the x. This would be negative 9y. This would be negative 27. Solve for y by dividing by 9. Y equals 3. Then you take that and you plug it into either of your equations over here. I'm going to plug it into the top one because it is so much easier. So x plus 3 equals 5. I subtract the 3 and x equals 2. All right, hope that reminder of systems of equations helps you with your proof.